Greetings. I have been asked to present a 10 minutes short lecture about how to determine the domain of a rational function for students who are already familiar with the concept of domain and range. Now, in order to make the lecture YouTube accessible and useful, and also because of the time constraint, I came to the idea of splitting the lecture into two sections. The first section I will be focusing, which is going to be this one, I'm going to discuss some essential background information. And in the second lecture, I'm going to focus on a special, particular example to illustrate how to determine the domain of a rational function. So let's get started for today's lecture, shall we? Now, there is a significant relation between rational numbers and rational algebraic expressions. Rational numbers are those numbers in the form of a over b, where a and b are integers and b, the denominator, is not zero. So maybe we can say those numbers that can be put in the form of a over b, where a and b are integers and b is not zero. In contrast, rational algebraic expressions are those algebraic expressions in the form of p of x over q of x, where p of x and q of x are polynomials and the denominator q of x is not zero or cannot be zero. Now, let's now talk about the essential difference between a fundamental term of arithmetic and fundamental term of algebra. In fundamental term of arithmetic, which is a theorem, which means deductively has been proven, indicates that any composite number can be decomposed into product of its prime, of its corresponding prime, in a unique way. And the fundamental, in contrast, the fundamental theorem of algebra, very similar to that, it says that any polynomial, we're talking about polynomial of non-constant and in one variable, polynomial can be decomposed into product of linear and irreducible quadratic factors. Now, I'm not going to go through the complex the decomposition of them, because the lecture is for developmental or basic algebra or college algebra kind of students. Now, the point is that neither of the theorem, neither the fundamental theorem of arithmetic nor the fundamental theorem of algebra indicates how to do it. He just guarantees, both of them guarantee, the first one guarantees that the composite number can be decomposed into product of its prime. And the second one guarantees that any polynomial can be decomposed into product of linear and irreducible quadratic, but it does not say how to do it. How to do it is another subject. As a matter of fact, for the polynomial, the fundamental theorem of algebra is an ocean of its own, how to do it. There are so many different ways, and you can talk about going to abstract algebra and Galois theory, etc., etc. Okay, then, that is for today's lecture. I know it was short, and next one is going also to be short, but I hope that they are all effective and beneficial to you. Thank you for watching, and have a nice, pleasant day. So long.